Okay, we're going to take a look at some arithmetic and geometric sequences. And what a sequence is really just a list of numbers that has a rule. And there's two different types of sequences here. We have an arithmetic sequence, and that means we're adding. And then we have a geometric sequence, and that means that we are multiplying to generate this sequence. Okay? So first things to start off with is number one. Is if we have an arithmetic sequence, this is like a linear function, and what this is we find a common difference between all of the numbers. So if you can see here, the difference between these numbers is the same. And what is the difference? If you just do 26 and you subtract 18, okay, so if you're not sure, go to your calculator. You're going to use your calculator quite a bit here. 26 minus 18, and you're going to see the difference is 8. Now, if I add 26 plus 8, if I keep going, look, I get 34 plus 8. There is the sequence right there. So the common difference here in this sequence is 8, right? Positive 8. You're heading in a positive direction, so it would be plus 8. Now, the difference with the geometric sequence is we're multiplying, and that's called a common ratio. So how do I get from negative 15 to 75? And then 75 to negative 37, okay? So in order to figure that out, we're just gonna do 75 divided by negative 15. And again, jump to your calculator, okay? If your number sense isn't great, right? 75 divided by negative 15. Even if you do have a good number sense, just double check, okay? And if I wanted to check to see if it works, I would do 75 times negative 5, and you see I get negative 375. Okay, so the difference here is we are going to get negative 5 as our common ratio. That means we're multiplying as we go up. We would go times 5, and we just keep going times negative 5, times negative 5, and we just keep going. Okay? All right, the next sort of step in understanding sequences is how to find the 66th term. Okay, now this is a formula that you can use, or if you wanted to, you can literally generate 66 terms and find it, okay? So what each of this formula means, and what's nice about these formulas is right away, A1 means the first term. Okay, so the first term is 3 plus n minus 1 times d. Okay, so if we're looking for the 66th term here, right, what we're going to do is substitute in the number 66. So if I do 66 minus 1 on the inside, and then I want to find the common difference. So I can see right here, I'm going up. The common term here is I'm adding 10 each time. I'm adding 10. If you're not sure, subtract. 13, right, minus 3 is 10, because we know it's arithmetic. We know we are adding. Okay, so if I substitute that in right here, and then I'm going to get the number 10 right here. Okay, in my calculator, I can say A sub 66. It means the 66th term is 3 plus 65 times 10. And again, jump right to your calculator, right? Jump right into your calculator. So we're going to get 3 plus 65 times 10. And that would give us the 66th term is 653, right? So you would say the 66th term is 653. And that's the notation that some of you should be familiar with as you're moving on into your next step of mathematics, okay? The next one is what happens if we have a geometric sequence right here. The formula is a little different, but notice that this is y equals ab to the x power, right? This is exponential, okay? It's exponential because we're multiplying each time, okay? So if we look over here and we figure out, well, how do we get from 6 to 18 and then from 18 to 54? If you're not sure, again, 18 divided by 6 is going to give us 3. So we're multiplying by 3 each time. So that's our ratio. So we use the letter R for ratio. We know that R is going to be 3. And everything else we know. Okay, so if I'm going to substitute in, I would say the 8th term. So I would say A sub 8, or the 8th term is the first term, which is 6, times the ratio, which is 3, and I'm going to raise it to the 8th minus 1 power. 8 minus 1. Okay, so now I'm going to go ahead and say, well, I know the 8th term is going to be 6 times 3 raised to the 7th power. Okay, again, jump into your calculator. Use your calculator a lot. So here I would say 6 times 3 raised to the 7th power, and you're going to get 13,122. All right, so here I would get 13,122 is the 8th term of that sequence. Now notice that geometric sequences grow much, much, much faster. That's a very, very large number. You can see it's geometric because we are multiplying. Okay, so that's how you figure out those sort of problems, right? And these sections right here, what you're trying to do is figure out, is it geometric or is it arithmetic? Okay, and you can see here, right, if I'm starting at 36, I do 36 divided by 6 is 6. 6 divided by 6 is 1. Right, so you would say this is a geometric sequence because we're multiplying, right? We're multiplying by 1/6, okay? So you would say that the ratio, you could say the common ratio is equal to 1/6 since we're dividing by 6, okay? So that's how you figure out those style, all right? And then we're looking at something like this, okay, where we're going to have to find the first 3 sequence of a sequence are given, okay? We need to find the 30th term of this sequence. So this is where you're going to go back and you're going to have to use your values, use your equation, okay? But first we need to figure out, and if you notice right here, the difference between this is that we're going down by 8, right? Okay, so our difference is -8, right? We're going down by 8, okay? So the formula for this, right? Again, we can copy it. We'd say we take the a of n is equal to the first term, right? Plus n minus 1 times the difference. Okay, so if I'm trying to find the 30th term, okay, we're going to take 403 and we're going to add 30 minus 1 times -8. And this is just a linear function, okay? But go ahead and substitute this into your calculator, right? So I would say the 30th term is equal to 403 plus 29 times -8. Okay, jump to your calculator, right? 403 plus 29 times -8. Okay, and just be very careful with your positives and negatives. And you can see that number is going to be 171. Okay? What happens if it turns out to be geometric? Now, this one's a little strange, but if you have the number 1, the only way to get to 5/2 and then jump to 25/4 is if we're multiplying. Right? So, and if you're not sure, just divide the first 2 numbers to figure it out. So if I take 5/2 and I divide it by the previous term, I get 5/2. So I know my R value is 5/2. Okay? So again, the formula just looks like A sub n is equal to the first term times the ratio raised to n minus 1. Okay? So if I want to find the 7th term, I take the first term, 1, the ratio is 5/2, and then I raise it to the 7 minus 1 power. Okay, so in my calculator, I would say the 7th term is 1 times 5/2. Whoa. 1 times 5 divided by 2 raised to the 6th power. Okay, now you don't need the 1, but let's just put it in there anyways. So I'd say 1 times 5/2 raised to the 6th power gives me an answer of 244.14. Okay, and they're going to ask you to round, so you want to make sure you round accurately to the nearest thousandth. So it would be 244.144, I think was correct. 2141 to the nearest thousandth. It's 3 places. 141. Okay. So that's it for the series. That's what you're going to be responsible for. Everything else is going to be extensions. All right, hope this helps. Have a positive day.